Hey guys, this is Craig Migliaccio with EC Service Tech, and today what we're going over are general purpose relays. So we're going over how they're used in the HVACR field, we're going over how they work, and also the troubleshooting. So this one right here has a 24 volt coil, this one has a 120 volt coil, and this one has a 240 volt coil. We power the coil to close a set of contacts and open a set of contacts. Now we have two sets of those on each general purpose relay. This one right here was manufactured without tabs in the center, and those are typically because they're used on fan center controls such as this. So we're going to be going over all these relays in this video. This video is sponsored by Danfoss, and you can check out their Cooling United support hub to access free HVACR tools and resources. The details are down in the description section below. I'm going to be going over how you read these readings in just a little bit, but first I wanted to show you how the general purpose relay works. Down here we have two wires attached to our coil. And this coil, when you apply 24 volts to this coil, it turns into an electrical magnet and it sucks down contacts on the inside of this general purpose relay. So from one side to the other is the coil, and it doesn't matter if this wire is attached here or here. It doesn't matter if this one's here or here. And it doesn't matter if these two are switched, meaning the hots on this side and the commons on this side, or the hots on this side and the commons on this side. So that's what you're going to be powering. It's on the lower section of the relay, and all these other contacts are up a little higher. But on the top of these general purpose relays, you see there's a wiring diagram. And it shows you that from 4 to 6 is normally open, so you can see that it's not connected right there. And on terminal 4 to terminal 5, it shows you that it's normally closed. So that's when the relay is not powered. But when you power the coil, whether this one's a 24 volt coil like this, or a 120 volt coil, or a 240 volt coil, when you power the coil, it's going to open and close sets of contacts. So this is all acting like a switch up here. So presently from 4 to 6, while there's no power down here, we are normally open, which is indicated on our multimeter, and we're reading a resistance value of OL, which means open line or over limit. So that means that those contacts are not touching, and if we were to switch one of these right over to the 5, you see that now we're reading 0.0 ohms of resistance, which means that they are closed. So now we're going to go ahead and power the relay, and you'll see that this is now going to read OL when I power this. Now we read OL, and now I'm going to go ahead and turn the power back off. We're going to switch our alligator clips up here. Now this reads normally open, which is OL, and now we're going to power the relay. And now it reads 0.0 ohms of resistance. So if this relay was bad, and say the contacts were pitted, then it may have a high resistance reading, and that would mean that the contacts are burnt on the inside. But if you're reading 0.0 ohms of resistance, then this contact right here on the inside is actually good. So you don't have to troubleshoot these while you're having the voltage go across here and while the amperage maybe is going across here to power a load. It's safe if you can disconnect your power wires that you're switching on and off here, and you're just powering the coil down here. So you're testing your resistance values across here. Now there's another set of contacts up at the top that work just the same way. So if you have say you're breaking a 120 volt wire coming into here, you're going to start that 120 volt wire on the 4, and it's going to come over to either the 5 or the 6, and then up here you could have a completely separate power wire, and you're going to attach that to the 1, and if you want something to be normally closed, it will be connected over here. If you want something to be normally open, you'll connect your wires here, but this is your input wire on 1 and 4. And just remember that your power wire that you're switching has nothing to do with your 24 volt coil down here. They do not touch at all. The wiring diagrams on these are typically always the same, but you're going to want to read them yourself just to check it out. But you see that 1 and 4 is the same up here. Even though this coil on this one is a 120 volt coil, you see that our wiring diagram on the top and the terminals are all the same. This one over here, same exact thing again, except that you're missing your normally closed contacts right here. And that's because this is usually mounted on a fan center control. So I'll show you that in a little bit. So I want to take this apart just to show you how this works, but it's pretty simple. You have this spring is pushing this iron core in the center, is pushing it upwards, And this iron core is actually sitting down inside this case down in here, this plastic case. So you have the wire wrapped around the plastic case, and on one side of the coil you have these tabs, and it's wrapping around and it's coming over to this side. So when you power this with 24 volts, it turns into an electrical magnet, and it is sucking this downwards because the spring is holding it upwards and the magnet is sucking it downwards. So basically this is going to normally be pushed upwards like this, and that means that this contact between here and this contact between here and here are normally open, and that's why you can see it up here. These are normally open and these are normally open. But the ones in the middle between here and here and here and here, those ones are normally closed because this is being pushed upwards. Of course, I'm holding this upside down right now. They are touching all the time. So between here and here and here and here. So those are touching. When the electrical magnet sucks this downwards, it's going to open up these contacts right here and here and here and here, and it's going to close these ones between here and here. So that's 4 and 6, and 1 and 3 is going to close the normally open sets of contacts. So that's how that works. So when it pulls it downwards, it's going to actually touch this connection on the inside right here. I don't know if you can see that. Here you have a fan center control, and you have a general purpose relay actually in this plug upside down, and so it goes right into these terminals right here, and you're going to notice that this particular one does not have any other terminals except these 4. So I picked a simpler version of these. There's ones with more wires and more connections, but on this one we are just connected to G and C. So the G and C are going to connect to these 2 plugs down here, and so that's going to be powering this coil right here. So let me explain how this works. So you have R coming off of this. This will be located in your, say, your furnace. You're going to have 24 volts coming off of this transformer. It's going to go to your thermostat, and it's going to be able to complete the circuit and, say, light up the display, coming back through to the C terminal, which is your common. When you turn your fan on, R is going to touch G inside the thermostat, and the wire is going to come back to G as the 24 volt hot, and then that 24 volt hot is going to come down here, and it's going to come into this plug, and then it's going to go across the coil in the general purpose relay, and it's going to come back out through the common. And that's why you have these 2 wires right here. When it does that, it's going to be connecting from here to here, because on the general purpose relay you see where we have 1 and 3 right here. That's normally open. And so when you power the coil, these 2 terminals are going to close, they're going to touch. And so you have your, say, your 120 volts going across here and going to power your blower motor. So let's take a look at the back. So you'd have one hot wire coming in for your 120 volts. It's going to connect when the coil is powered between here and here, and it's going to allow the voltage to come out and go to the blower motor. And just so you know, these 2 wires are the 120 volt wires that would be connected to your transformer in order to power your transformer. So you see this one has a 24 volt coil between these 2 taps. This one right here has a 120 volt coil, and this one right here has a 240 volt coil. So you can have different control voltages for the coil depending on the model number of the general purpose relay you use. But regardless of the coil voltage, the lower section right here is always the coil. So you see these 2 taps here. And the wiring diagram on the top is usually always the same. So it's just going to depend on your ratings right here and your coil voltage. Now on the back of this, you see this one right here, and this one has the rest of the ratings on the back. This one has them on the front still. So this whole side is referring to the contacts and not the coil now. So this is a 12 full load amp rating, so the contacts should be good for a constant amperage of up to 12 amps running across the contacts. Now the locked rotor amps is during that first quarter second when a motor turns on, it can handle up to 60 amps, but it must fall down below 12 amps to basically not burn out those contacts. And over here you see that it's a 6 full load amp rating for the higher voltage across those contacts. And the locked rotor amps is lower as well, and that's 35 amps for that first quarter second when a motor turns on. So those are inductive amperage ratings. Down here is a resistive amperage rating. So you could draw a steady current of up to 15 amps across the contacts, and that would be for something such as an electric resistance heater or something like that. And so you know the VAC just means it's alternating current voltage. Now over here you're going to see, if you can make that out, it says AFL. So that is the same thing as FLA. It's the amperage at full load. And this right here says ALR, and that's the same thing as LRA. Right here it's a locked rotor amps, and so basically it's just saying amperage at locked rotor. Also remember that when you're testing the contacts, they should either be OL or 0.0 ohms of resistance. You shouldn't have a resistance reading across them such as like 5 ohms or 10 ohms or anything like that. That means that the contacts are not making a good connection and that there's maybe carbon dust in between them, or maybe there's pitting and it's just not making a good contact. So a relay that has something other than OL or 0.0 ohms of resistance would be bad. And down here on the coil, if you read OL, then that means that the coil is burned apart. So you should have a resistance reading across that coil down there. So here's an example of another coil, and this one reads 21.5 ohms of resistance across the contacts. So that coil is good. So general purpose relays, they're used quite a bit in air handlers and furnaces. So you want to have these stocked in your truck. I have a 24 volt one, a 120 volt coil, and a 240 volt coil one stocked in my truck. I actually have several of each type just to make sure that I'm going to be able to get the systems up and running again. So you want to have these stocked in the truck, as well as fan relays and contactors and sequencers. So they're all very, very useful in the HVACR field. I also have a bunch of other videos on HVACR switches and relays and their troubleshooting down in the description section below. Make sure to check out our free resources over at acservicetech.com. We also have our paperback and ebook available there as well, along with the full outline. This paperback is also available over at amazon.com. Hope you enjoyed yourself, and we'll see you next time at AEC Service Tech channel.